running, and then it will consume the cred. You should finish the exercise, and so for example, let's say if one exercise says you create 2 VMs or 3 VMs, and you create 1 VM at the beginning of the week, and then you create rest of the 2 VMs at the end of the week. That whole week, that VM, if that VM is running, it is going to consume your credit, right? So you need to. That was the one of the first principles, along with technical details I told you. You need to take care of the cost part, and your own account also is part of that, right? And secondly, we don't have an alternative. Even though I have one subscription which allows me to take 10,000 rupees credit every month, but the moment I share it and you guys start using it, is going to expire within a day. So it's not going to help, right? The institute cannot serve it, obviously, because they won't be easy. It won't be easy to control the cost. We have already spoken about these things, so you need to be doubly careful about how you want to learn from this course. If you don't have any practical resources left, then how will you perform the experiments and all, right? So you need to be very careful about the cost part. Every exercise you do, it will, let's say if it takes half an hour or 1 hour, you will hardly spend like 50, 60 rupees out of the $300 credit that you're getting. But if you just let it run forever and you do not lead the resource group after the end of your exercise, obviously it is going to get consumed. Okay, so you need to take care of that. And one alternative is you can check with like Google Cloud how they offer, or Amazon. So you can do an equivalent exercise in those clouds also. It may not have same nomenclature about availability set. Instead of availability set, they will have availability zone, for example, or some other concept. But as we progress further into more broad-based technological concepts like anti-error architecture, load balancer, everything will be similar in all clouds. Just the names will be different. So you can use Google Cloud account, you can use Amazon account, and you can also create multiple email IDs and use those email IDs in Azure. Each email ID they will get a $300 credit, or I think 1 month free kind of thing, something like that. So you need to figure it out. But I'm sure there is a way to do so. But the key thing is you have to do it. There is no support, unfortunately, because of the cost involved. Okay, so you please be careful about that. Okay, that said, let me share my screen and we can start. So, do you have anyone has any doubt, any challenges that you faced in the implementation of anti-error architecture? If anyone tried that in yesterday's lab time, are you able to do it or understand it? Any questions? No questions? All right, if that is fine, that's fine with me. Okay, so we discussed anti-error architecture deployment on Azure using virtual machines, and we discussed the nitty-gritty of it. And the assignment, I think it has a solution which you can just deploy right away, but if you want, you should try doing yourself using some ARM template or set of AGCLI commands. That should also be really helpful. Now we'll move further. So what we discussed here is we discussed that there is a load balancer here in front of the boundary or application that is running on the server side. Right? This is our virtual network, and basically it is running the application. Right? So what is the job of load balancer? This load balancer, can somebody tell me what is the task of this load balancer?
It distributes the requests among the VMs.
It distributes the requests among the VMs. Right, very good. So what is the basis it does, on which it does? So how does it do it? So one request comes, so how will it distribute to this or this? How will it choose? Hmm? How will it choose that distribution? Can somebody tell? How will it choose the distribution?
Sir, so at first it seemed like the response was coming randomly from any one of the VMs. But if for example, if the load is very much on the load balancer, then it will assign. So it will randomly pick one VM and assign some request to it. And if the number of requests already in their process are more, then it will assign the now incoming request to the another VM. So it will work dynamically, basically. Or
No. That is not correct, actually.
okay.
See, load balancer, I think we talked about it. It's not randomly going to put it. So that is not the right word to use. Load balancer has a table or a list. You can say it's kind of a table of all the IP addresses that it is linked to, right? So this is the load balancer, this is the incoming request, this is the outgoing end, and to the outgoing end we have got different VMs attached to it, right? That's how it is. So if it has three VMs, each VM will have an IP address. Let me say it's IP1, IP2, IP3. So in load balancer will have a table IP1, let's say on, right? IP2 on, IP3 on, right? So what is this on and off thing? So this is like available or not, availability, and availability and IP. So the load balancer will keep probing them. Okay, it will keep pinging the VMs to know that they're running, and it will keep them updated in the table that whether I am able to reach that VM or not. Okay, so in most times it will do the distribution in its round robin fashion. So if first request comes, it will pick the top IP address. Second request comes, it will pick the next one. Third will come, it will pick the next one. So it is not very, it doesn't have any heuristic, any uh, complicated algorithm to pick. It is surely not random. Okay, so it basically has a table, and if some VM goes off, let's say this VM is not available, it is off, then obviously it has this much intelligence that it will not pick this till the IP2 becomes available again, right? So the round robin, it will IP2 will not participate in the round robin fashion. So that is how the load balancer will distribute the load between the target VMs. Okay,
Yes, sir.
and
So,
it
sir, I
could,
have just one question about this.
yeah, sure.
Sir, so when I performed the assignment, and so at last the last step was to refresh the page a multiple number of times so that we can get the response from different VMs. So
Mhm.
there I noticed that sometimes on just refreshing one time, the VM means the response I got from another VM. But at times it happened that I am refreshing for around 5 to 10 times, but still I am getting the response from the same VM. So how
Okay.
is that, and why is it so?
Yeah, so good question. I my only guess will be that it might be also looking at that whether that VM is busy or not, serving a request. Okay, so it might happen that instead of pure round robin fashion, it does check the load on a particular VM. So if you send a request to one VM and before that request gets served, if you send another request, it will surely go to the next VM. But many times it is because we are like performing a small experiment. It is possible that that VM serve the request even when you before you even click the second time. So there is a tool called JMeter. So JMeter and even I think Postman, also Swagger, but I definitely JMeter can be used to load a system with the multiple requests at the same time. Okay, you can use JMeter to experiment further and try to see how that happens instead of manually refreshing the page. Okay.
Yes, sir.
And
Thank you.
then see how the load balancer works out.
Yes, yes.
Okay, good. So I hope that it is the point point to notice before we move to the next thing is this, that load balancer operates at IP level. IP or that is network address level, right? So let's suppose I have this requirement. So this is an IaaS solution we are talking about. So I have VM1, VM2, and VM3. This VM, now cost is also always my, what you say, concern, right? So this VM, so my requirement is that I want to process some, let's say, image processing and some image or video processing or something like that. So it's some heavy duty stuff. Now, let's say for we don't still right now it will be something like this is like web tier and then the processing is happening in the business layer, right? Like that. But let's assume for the sake of simplicity that our web tier and business layer is same machines for now. Okay. Now for image processing, image or video processing, I need a higher CPU powerful machine, more CPU cycles per second, right? So I have configured VM3 as a high performance compute, right? But VM2 HPC, my options are I can consider 3 as HPC, but because of the cost, I do not. These are the regular ones. Okay. And this is HPC. Now, when the request come, and here we have got the load balancer, right? So when a request is coming, this load balancer will simply distribute the requests as they come. So first request is a normal request, fine. Second request is a normal request, that's fine. Third request is again a normal request, but then fourth request is a video processing request. Fifth request is again a video processing request. Sixth one is normal request. Like that, the requests are coming. So if we leave it to load balancer, because it just operates at IP level, it will simply distribute the load, and sometimes the video request will not go to the designated VM because there is no way in the load balancer to specify that you should put some particular request to a particular machine, right? So now when I designed my API, the web API that I designed, this is on the server side that 3 VMs are running, and I have that web API, and for the normal request, that is the URL http my app, right, / normal request nr, right? That is the URL for normal request. But for video processing request, I have my app / video, let's say video, okay, or / image and then you have the stream of the video or image for upload or processing, right? So this is in the parameter list. Basically, what it means is that I can distinguish the request, what kind of request it is, from the URL itself, right? So I can identify that in this URL, this is the video or image processing request, right? And this is a normal request. So there is a way in my incoming request. So incoming request has that information implicitly, because when somebody from the client side is uploading the image, it is using this /image URL, right? So obviously, because it needs to invoke this URL, the image URL. So at the URL level, I know, or there is a way to distinguish or identify which requests pertain to video and image, right? So it would be nice if I had something over here which operated at the OSI level 7, right? The layering of application, right? The top level, then top level is the app level, then you have some platform, or there's a network layering, right? So there is a TCP IP level, then, and then you have got MAC address level, and then you have got, like this, there are 7 hardware levels. There are 7 levels of application layering, okay? So at the top level, we have got the URL, because URL belong to the application. Nobody understands at the below level what is the URL. This guy understands the IP address, right? With port or without port, right? URL is identified at the top level only. So we have got a URL level or top level way to identify the type of the request. But our load balancer operates at TCP IP level, where they have no clue. Anything that operates at TCP IP level has no clue about anything above its layer, right? It can understand layer IP address, it could understand probably MAC address or anything below it, hardware, but it cannot understand anything above. So unfortunately, even though there is a way to identify and discriminate, that I can say, if there is a logical way to doing so, like if I can write it like if URL dot substring, right, has /img, or URL dot substring has /video, then send request to VM3. Something like that is possible, right? Logically, I have this information, but this kind of information cannot be utilized at TCP IP level, which is the load balancers level, right? So what can I do? So for that purpose, we have got something called, and this is our special VM, a application gateway, or it is also API, depending upon whether this is targeted as a web application, complete application, or whether it is a only API providing. So application or API gateway. So application or API gateway. So application or API gateway is a service which operates at app level, or basically it means it can identify the URLs, right? So when the input request is coming, we can configure it that if there is a /image in the URL or /video in the URL, send the request to this VM. Map the request to this VM so that we can process those VMs high compute requiring requests. We can assign them to the resource which is appropriate for that. Okay. So we can replace load balancer with the application gateway in the front of the architecture here. So instead of load balancer, we can put here an application gateway. So application gateway will perform the same distribution of requests, but it has more capability. It can do what load balancer does, but it has more capability of switching based on some logic at URL level. Okay. We have another properties of application gateway, but I remember from last class there was a small discussion and I want to bring it up. It was related to load balancer. So let us go there first. So let's consider this, right? So why we are creating 3 VMs, and obviously these VMs in one availability set, right? So why we are putting these 3 VMs of same role in one availability set? What is the idea behind it? What is the goal?
To increase uptime.
Sorry? Come again? You were right, I guess. What were you saying?
To increase uptime.
Right. So that uptime, to increase the uptime, that is right. Meaning for high availability, right? So high. Can you guys hear me?
Yes, sir.
Okay. By mistake, I pressed the airplane mode in my laptop and it got disconnected. Okay. So we are putting the 3 VMs in any tier in an AV set for high availability. But there is a load balancer also, a component. What about this guy? We don't have 3 load balancers. What if this guy goes down? Right? If load balancer goes down, this AV set is not going to receive any request. So what about, isn't it the load balancer which is the bottleneck here now? Isn't it the load balancer which is going to affect the high availability? Because we got the high availability at the VM level by putting the 3 VMs in one AV set. But there is only one load balancer. There is no backup for it. What if it goes down? Isn't this now the bottleneck? Right? So what is the answer to that question? So answer to that question is, the question is very good. The concern is very genuine that there could be, we have this issue of high availability that we must ensure, but there is only one load balancer. The answer to this question is that the probability of load balancer going down is very low because it is very close to being a simple, it's a hardware and it's a very simple hardware. It has simple table lookup mapping table which can be configured and nothing else. It's basically some set of registers which can be loaded with some information. That's all. Okay. So it's just like the router in our homes, right? It seldom fails. In my whole life, since I have been using routers, Wi-Fi routers, it has never failed so far. Because it is a simple hardware, right? So the answer to that question is that the question is correct, the concern is genuine, but it is not. It is not going to happen with high probability, or the probability of such happening is very, very low, such that the companies don't ask you to put load balancer also in the same AV set just because they need for high availability. Anyways, putting single load balancer in availability set is as simple as so good as putting single VM in a single availability set. So the answer is that load balancers are simple hardware based equipment which is very, very unlikely to fail. That is why this is not a concern. Okay, I hope that makes sense now. So coming back to the application gateway, so we have that scenario that we discussed, where we wanted to discriminate based on the URL of the application, and we replaced the load balancer which is in the front with the application gateway. Okay. Now we don't want to do that for everything, every load balancer that we have got here, because now this thing is in our control. We can, process the URL, and maybe let's say if this was the VM that is coming to for which the image and video URLs are coming in this VM, maybe this guy is sending the request to a dedicated hardware of more VMs, right? Then we don't need to further put a application gateway anymore, because it won't make sense. Now it could make sense if this was the only reason. If image or URL based discrimination is the only reason, it becomes unnecessary, because now it is in our control and we can control what goes where. Now what one second, why this is coming up again? Okay, so what other roles the application gateway could play? Okay, so web traffic load balancer enables us to manage traffic to our web applications. Okay, it operates at application level 7, OSI level 7. Okay, traditional load balancers operate at transport layer, right? OSI level 4, which is TCP and UDP, and therefore they route traffic based on IP addresses and ports, not on the basis of URL. The application gateway can route the traffic based on the URL. Okay, so this is an important capability that you get if you put application gateway in front of your web deployment instead of a load balancer. Now, another advantage is SSL termination. So what is SSL termination? Suppose you are, or I think that might be useful. So let's suppose that you have incoming request from the client side that is encrypted with your encryption, right? Public key encryption. Public key encryption, the request is encrypted. Encrypted request, right? Now, encrypted request is coming here. It goes to, let's say, this VM, which is running some code. So code, I will write, say, C1, because both VMs are doing the same thing. We will be deploying the same code on both VMs, right? That's how they will do the same thing. C2, both, all these three VMs are equivalent. So why? Because we are deploying the same web handling code with them, right? Then C3, same code for business tier, and then further, right? Now the request comes here. Load balancer sends this request here, C1, okay? And this is only basically it can decrypt the request, right? it can decrypt the request. So request becomes a decrypted request and then goes further. So this decryption is part of my code now, right? It is part of my code, and it decrypts the request and then goes further. Okay. Now remember what is the role of DMZ layer. The role of DMZ is it could be simply checking for some parameter, decrypting the request, right? But it may not be able to get into the details of the request, right? What are the different parameters, what is where, everything like that, right? So it might happen that it is decrypting the request, but this request is complicated and it is not right to put that decrypted code in the C1. So it could be that C2 also have to it receives an encrypted request instead of decrypted request, and we need to put encryption decryption code, ED code, here also, or maybe here also, right? Meaning it could be the case that our encryption and decryption code is spread throughout our application. Now that could be a requirement, right? It could be a requirement that my requirement is that every tier should have, let's say every subnet, this is the subnet we discussed, right? These are the subnets. So what I'm saying is that every information that comes out of this subnet should be encrypted request. It should be encrypted, right? So I will have to put decryption code here also. Then the from web tier to business tier, I have the requirement that it should also be encrypted request. So then I have to decrypt the code after I receive it, right? And so on, right? That could be requirement. If that is the requirement, then we probably don't have anything else to do, because if it is mandatory that every subnet has to output it in an encrypted form, and therefore we will have to have a decryption code in every layer of the application, right? That could be possible, or that could be required if they are like the web tier is in a different data center or region, business tier is in different region, they are separated by internet. But what about this when they are all in the same virtual network, right? Then this is all within the same virtual network. They are essentially within the same data center. So there is no internet involved, right? So this could be a hard requirement, need not to be required in most of the cases, right? So it is not a requirement in most of the cases. So we don't need to have decryption code in different in every layer of the application, right? So what we can do is we can put the decryption code in the application gateway. It decrypts the code. So when it decrypts the code, why it decrypts? Because the request from internet is coming to application gateway, it decrypts it and sends the normal, like non-encrypted code, like a plain text. So the request becomes plain text from henceforth onwards. So the moment the request enters the virtual network, it is a plain text. So I don't have to deal with writing encryption, decryption logic in any of the web tiers, right? Because now my whole application doesn't even know about encryption, decryption. I don't have to worry about it. I will just deploy a small component in application gateway, providing it the decryption private key, and the incoming request it will decrypt and send the request. When it is distributing the request to the VMs, it will replace the request data with what it has got after decryption. So it will be a plain text. So my whole application which is deployed on this virtual network does not need to worry about the decryption part, right? So it is called SSL termination, meaning you are terminating or ending the SSL, the encryption, right in the application gateway itself. So that is why it is called SSL termination, because it supports terminating the encryption at the gateway itself so that data travels unencrypted to the backend servers, and obviously then it saves the overhead. Why? Because now you don't have to, your whole rest of the whole application doesn't have to deal with the decryption part of the code, right? Decrypting the code. Okay. So any questions about SSL termination? All right. So what are the other advantages? Web application firewall. Right? It acts as a firewall. So you can configure it to allow some requests or not allow some requests. It will guard against common exploits, just like a regular firewall does, right? It will, you can use it as a firewall. Then multiple site hosting, redirection, and session affinity. So multiple site hosting, redirection, and session affinity. So what basically does is that application gateway, here application gateway is matching to one application, right? But you can actually have multiple site hosting because it is based on URL, right? So you are saying that myapp.com is the base URL, but it is still a URL, right? So because it operates at URL level, right, traffic based on URL, I can actually deploy two websites on the same web server, put an application gateway in front of it, and configure such that myapplication.com requests are going to one deployed application. myapplication2.com requests are coming to this application, separate deployment. Because it's again basically the difference in the URLs only. So therefore, application gateway or API gateway has got this capability of multiple site hosting. Redirection, like I said, it can redirect the request to a particular VM based on the URL. So it can redirect that. Session affinity, it is similar like if, let's say, when the request comes and it goes to the first VM, the session is established against that VM by the user, right? So this is the session. Now, if the request goes to other VM, it might cause the session to terminate or be different, right? So if we have a session affinity, we can, if we have a application gateway over here, it can always send the request to that particular VM if as long as the session is there. So it has that kind of affinity. Or you can attach a particular VM to a session. Once that session is over, then it goes away. But during that session, it will always send the request to that VM only. So that is session affinity. Was there any question?
Sir, can you repeat what is session affinity?
Yeah, sure. So what I was saying is, when the internet request comes, so sometimes you interact with that person, you establish a session cookie, right? So the cookie is stored on the client side, it is validated in the code, and then that session is validated, and you don't have to repeat, or you don't have to ask your user to repeat the login or repeat the validation or things like that. So suppose that session affinity, session code is has run in this VM for that particular request, right? So this VM has generated a cookie, even though the code is same in both VMs, but this VM has generated the cookie. This guy doesn't know about it. So this VM has generated the cookie, kept it, and sent the request back. So now the session is established between this VM and the user, right? If the same user sends the request and it goes to this particular VM, that code may not be knowing about the session cookie. Okay, so it will generate another session. The previous session cookie will invalidate and it will become a problem for the user. It will not use the data in the previous session's cookie. So maybe, for example, it will ask the user to log in again, things like that. So that becomes a problem. So if you have an application gateway over here, and in that case, when the session is established with this particular VM, the application gateway has capability that for that particular session, meaning it will identify the session cookie and it will send the request of that cookie only to this particular VM. Okay, that way the session will not be terminated.
Sir, if the user connects next time, then if the first VM is busy, then where the request will go?
Okay, good question. So it is not necessary that the user connects the next time. Basically, what the question is that if the session is still available, but this VM is busy, then what to do? Now that is the configuration that we need to see which one will work for us. If we are okay with the user waiting, having to wait longer, little bit longer, so that VM can serve the previous request, then we will enable session affinity, because if the session affinity is enabled, application gateway is not intelligent enough saying that, okay, this VM is busy, then I will send it here. At least I don't know, maybe it has that configuration, but I will assume it is not. All it will tell is that if you can sustain the session, please do so. So it will wait for that VM to be available. The request will be in the queue. It might get a little bit latency or delay to get back to the user. Okay.
Okay, sir.
So that is the session affinity. So these are the advantages of putting a application gateway or API gateway in front of the deployment that we have got. Okay, so that is the role of the application gateway that can come. So related to application gateway, there is also something called traffic manager. So this one, traffic manager, right? So what is this traffic manager now? So what happens is, see, one of the reasons why cloud has come into picture is availability, right? Availability is the primary goal. Okay. Second is scalability. So what is availability? Availability means how long your application is up and running, and whether any requests get or all requests get served, or whether any requests get skipped, right? So the application that we are going to deploy is going to be deployed in a particular region, right? So let's say if I deploy the application in American region, okay. Even though I deploy the application in the American region, okay, let me draw it from here. So let's say, so if I open, let's say www. Amazon.com. Let's say this is the website. Okay. So if I open it from US, it opens. From India, it opens. From Europe, it opens. Meaning the web address is unique or universally or globally available, right? Globally visible, we can say. Meaning I can log, if I am connected to internet on anywhere on the earth, I can log on to amazon.com. For user, it is available everywhere. But what is the deployment story, right? Amazon.com is a page, right? Amazon, www.amazon.com/home or index.html plus the CSS files, plus the JavaScript files, plus resources like images, etc. Right? All these are going to come to the browser, and then what is what you are seeing here in different regions, the website page. That website page that is coming up here is basically the browser rendering this whole stuff that it has got from the web server, right? So that is what is happening behind. Now, this stuff is coming from some web server. That web server could be either a VM or a machine, hardware machine, or it could be a platform as a service, no matter what. But ultimately, there will be a hardware involved there, right? So hardware cannot exist virtually. It has to be physically existing somewhere. That means it has to be in some data center location, right? If it is in a data center, then it means it has to be in some particular region. So even though for a user, the application or web app or website is globally visible from anywhere in the world, ultimately the request is going to come to a particular region from where this bunch of information is getting served. So this region is not virtual thing, it is a real physical boundary, right? That's we already know. So here there will be the web servers lying which will be serving the request. So ultimately there must be a hardware lying in some region or some place from where the request is getting served. If that is the case, then we have this global thing. So person sitting somewhere on this area is requesting over the internet. The deployment is in this area. This is the data center, and the request is coming back, right? A person sitting in the same region here, sending the request, getting the back. So do you think person A and person B are going to have the same experience while seeing the website? Any guesses? Which person will see more latency? Any guesses?
Person A.
Yes, person A will see more latency because the distance involved in this diagram, rough diagram, is much more than person B. Okay, so when I said that it is visible from US, from India, from Europe, that was very high level thing. I did not tell that how long does it take to place an order at amazon.com or things like that. So it means not only do we have to deploy the data application in particular region, we also have to make sure that the end user experience is very good, right? For that, the latency should be low. That means I want to deploy application in some other regions also, right? So that instead of this distance, this request going in that far, it goes here, right? So now person A and person B are likely to have similar experience, and so goes for other regions, right? So that means a single application This is very important to understand idea-wise. A single application can have multiple region deployment. Data center 1, data center 2, data center 3, and so on. It is important to understand this. When I say single application, what does it mean? What does this single application mean? Single application means I always, no matter where I am sitting or from where the request is getting served, I am always typing amazon.com. I don't have to type amazon.com DC1, or I don't have a separate URL says amazon.com underscore DC1.com. It's nothing like that, right? It is always amazon.com. So that is single application. If I place an order, I don't have to specify or bother about where the order is coming from. Meaning where my order is getting placed in terms of where it is getting stored in the database. That means if I have to give that kind of experience to the user, that users are completely oblivious or not knowing about from which data center it is coming, the requests are coming, that means the data centers need to synchronize with each other, isn't it? They have to synchronize with each other, because if I have 10 items here in this data center's database and the request is coming from this, it has got only 2 items, so 8 items are missing when the user is coming from this data center. But this user is saying 10 items, so I don't want to, can't afford these kind of differences. So in the background, if I added 8 items just a while ago, in quick time, these items should sync up with the data center 1 and 2, so that any request coming from data center 1 also shows not 2 but 10 requests, 10 items, like data center 3, right? So there must be a backend system, backend synchronization between different data centers. So as you can see, this is quite a bit of challenge, right? So that is one part of it. The second part of it, why I would deploy a single application in different regions is this. Region 1, region 2. Suppose this region goes down, I can continue to serve the requests from region 1 and vice versa, right? So it is a backup also, or redundancy put into system. Because Amazon can afford, for example, one whole region going down, but it cannot afford that because of that region went down and it could not come up back up for a week because of earthquake broke its building. It cannot afford that whole week Amazon.com being down, right? So this is availability in terms of continuously being there, right? This is more like scalability and latency. So there are two overarching reasons why multi-region deployment is necessary for many applications. Okay. So if I have, let's say, incometax.government.gov.in, okay, or let's say I'm a tax expert on Indian taxation system, and I run a website, ask any question about indiatax.com, right? So ask any question about indiatax.com, obviously that application is meant more for Indian customers. For such application, even if somebody is requesting from US, it will get the request back, because over the continents, the fiber cable will bring the request to my India data center, because I deployed that application to India data center. It will serve the request and send the information back through the fiber cable over the oceans, and send the information or show the information on that computer. It might take time, but it will get through. Now, is that an important scenario for me Probably not, because my target audience is only in India. So I will deploy that application in Indian data center of Azure, Central India, and be done with it. So multi-region deployment is not required for all kind of applications. But if I am running a business where my customers are in US, in APAC center, Asia Pacific center like Japan, Singapore, China, Europe, then I can't afford a single deployment in India data center and be happy about it, right? Because the customers will take long time to even see the information. So it is going to be business loss for me. So I will then consider deploying my application not only in India, because India is a customer base for me, but also in US data center, in Europe data center, and Asia Pacific region. Okay. So that way, these are some of the reasons why multi-region deployment could be required for a particular application. Now, multi-region deployment, if that is required, then somebody has to manage the traffic, right? Which request goes to which region? That is done by the traffic manager. Okay. So in the NTR architecture, in the multi-region deployment, you have got this asynchronous replication between the databases, right? So asynchronous replication meaning there is a technology called SQL Server always on technology, meaning you can deploy SQL servers on different machines, connect them through some network like this, and then configure that these 4 nodes, 2 nodes here, 2 nodes here, should be what do you say, in sync. Set up always on for them. So automatically SQL Server will synchronize the data between them. It will be a synchronous replication. Okay. So for this to do, this yellow arrow to work, these 2 virtual networks that are here and here, they need to connect with each other, right? So for that, you first do at a network level virtual network peering. So you pair them out, meaning you connect them, and then you basically set up the synchronization between different nodes of the SQL Server, and the synchronization will happen. Okay. Now, what is this cloud witness? Cloud witness is like, for example, let's say there was data whose value was 1, 1, and 1 all over here. Okay. Now, when the update is happening, the data became 2, 2, and 2 over here. Okay. And this is still 1 for some reason. And the request comes to give the data back. The read request comes before this 1 become 2. So how does it decide that whether 2 should be returned or 1 should be returned? Okay? So that is the job of something called cloud witness. It basically, it's a kind of a quorum based or majority based system, that whether the quorum is established, and then once established, that data is considered to be the real or true data. So when I'm saying that 1 got updated to 2 on these 3 nodes, the quorum got established. Let's say the majority of the nodes have got the latest data. So when the new request comes for read request, even though 1 node has got this older data, the quorum says the request or the true data value is 2. So 2 will be returned back. So that quorum or decision making of this data is something done by the cloud witness. Okay, just to break the ties between if the data is not same. Now this is interesting because such situations don't come often. Now it is very common because this multi-region deployment and cloud coming into play. The multi-region deployment is not only left to large companies. Even smaller companies do that, and we need to be worried about how this thing will synchronize in between, right? So quorum thing is the answer to that question. Now somebody might ask, sir, what if this 1 1 and 2 2 are there and 1 1, so number is same? So the answer to that question is that when the 2 1 was getting updated to 2, it is a transaction, right? So that transaction will not be done until a quorum is reached. So as soon as the quorum is reached, the transaction is done. Because now I know eventually this will also become 2, but I don't care if it doesn't for some time. So I don't waste time to wait for it to become 2, because I already have quorum updated with the latest data. So that is the that are the details. So this is the multi-region deployment scenario for NTR architecture, right? And that is managed by the traffic manager in front of it. Now here, one region is designated as a primary region and another region is designated as secondary region. So that is why what you see over here is the arrow is from the primary region to the secondary region. So in what I think what is depicted in this case is that all the requests will go to primary region and secondary region will act only as backup of the region. Okay, we'll see about the modes of the traffic manager in which it operates. But ultimately, this is these are the reasons why and what are the necessary things that we need to do for multi-region deployment. Okay, and these are the application gateways or load balancers, as the case may be, depending on whether you need discrimination based on URL or not. Okay, whether you need SSL termination or not. Traffic manager has nothing much to do with the application level things. It has to take care of region level distribution of the requests. Okay. Active Directory. What is this Active Directory? Active Directory is basically what you can think of it as a dictionary or as a user base which automatically syncs up between different regions. And Active Directory or Kerberos or I don't know what about Mason's thing. They are basically for user authentication. So whatever users you register in Active Directory, and then you can authenticate against that Active Directory if some user logs in from anywhere. Okay, so what is the role of a traffic manager in multi-region deployment? So traffic manager allows users to control traffic distribution across various application endpoints. Okay. Traffic manager distributes the traffic using the configured routing method. So how do you route the request from internet to any of the two regions? That is done by selecting the routing method of the traffic manager. What are the routing methods of traffic manager? It could be priority, weighted, performance, and geographic. Okay. What is priority? Meaning which region is given more priority. I'll set the priority to my primary region. Then that is based on the priority. So as long as that region is up and running, the request will go only to that region. Weighted, I can say that 60% of my traffic should come to primary, 40% to my secondary. So you can weight it out, weight the incoming traffic, volume of the traffic. So you can split it based on some ratio. Performance. So you can mention that whichever is having higher performance, meaning if the latency is going to be low for a particular region, then don't send the request to that region. You send it to the other region. Geographic, you can say that if the region request is coming to from a particular region, then route the traffic only to this particular data center. Like for example, there are some requirements that if the request is coming from European Union, the request of that particular application, maybe it requires some data that is getting stored from that request to the database in this region, right? So then this region is only going to be has to be in Europe because of some law, right? So then the traffic manager can mention that, okay, my incoming request is originating from somewhere in the Europe IP address. So therefore, I will always send this request to my Europe region. So that is the geographic thing, okay? Then it monitors the endpoint's health, like which region is up and running, and then keeps sending the data until the health is up. Automatic failover in case the endpoint fails. So if the endpoint fails, so if my primary region fails, it will start sending that information to the secondary region. Functions at DNS level, meaning it will route the clients to precise service endpoints according to the traffic routing rules and methods. So at DNS level, it operates. So you can, it will send the request according to that. And these are the operation modes. So as you can see, I'm deploying so many resources on primary and secondary region, right? So based on the cost factor, I might decide that my secondary region will be a low cost region. My VM's quality is low because I want to reduce the money spent. But I still want to have one application, one region available for running, right? Or I want to keep this off for some time, things like that, because to save the cost. So you can set the mode of the traffic manager. Active, passive, hot failover. What active, passive, hot failover means that traffic manager, you can assign one region, like primary region as active region, secondary region as passive region, and if it is hot failover, the secondary region will be up and running, the VMs will be up and running, even though all the requests are in the primary region, right? Why it is up and running? Because if the primary region fails, there is no lag of serving the request. Traffic manager will immediately start sending the request to the secondary region, okay? Hot failover means the passive region is up and running. Cold failover, now, cold failover is, what is the difference between hot failover and cold failover? Cold failover is, because if I am saying secondary region is up and running, it is going to cost me. So what I opt for is cold failover. When the primary region fails, only then the secondary region's VMs start, right? So there will be 5-10 minutes of delay in serving the request, but the cost reduction will be there. So the VMs will be switched off, the secondary region is not available, but it will be triggered to be available, or it will be booted up when passive the active region fails. So that is cold failover, right? And active load balanced, like weighted, like it will be both active and it will be load balanced. There are other ways, like primary region will be for all kind of requests, secondary region could be used for read-only requests. Those kind of things can also be done. So this is how we can manage the multi-region deployment also for the NTR architecture, right? So as you can see, there's lot of detail in terms of just being able to deploy this simple NTL traditional architecture onto the cloud. The whole idea behind NTL architecture being available on the cloud is to enable the migration, right? So much important it is that you have got the detailed architecture recommendations for a single region deployment as well as multi-region deployments, and you have got tools like Traffic Manager, Application Gateway to further fine-tune the requirements, fine-tune the availability of different artifacts that you have in Azure so that it can match to what the customer's requirement is. A customer wants to discriminate at the URL level, yes, Application Gateway can be used. At IP level, feel free to use the load balancer. I want to deploy in multi-regions, sure, you can go ahead. How do I coordinate between different regions? Traffic Manager is there, right? So as you can see, cloud service providers will provide a lot of tools and capabilities so that the migration is easier, or you can replicate the migration that you have. Let's say one company has a data center, hardware data center of on-premises data center in two regions. They can simply migrate the one data center to the closest Azure region, other data center to the closest Azure region of that data center, and connect the two sites through a traffic manager, and they will be up and running in no time. And their whole data is application is migrated to the web. Okay. So this is the detail about the NPR architecture with single and multi-region deployment. Okay. So I think we are out of time. Any questions? Anything? Okay, great. If there are no questions, then we stop the recording and be done with it.